Is the world you perceive truly real, or is it a carefully constructed illusion? The chair you sit on feels solid, a tangible object supporting your weight. The colors you see appear vibrant, a dazzling spectrum painting your surroundings, and the sounds you hear seem to come from definite sources, clear and distinct in the air. Our everyday experience insists on an objective reality, a shared understanding of the world around us, and we trust our senses as a window onto the world, providing us with accurate information. Yet our senses are easily fooled. They can be tricked and deceived. Optical illusions show us lines that look curved but are straight, challenging our perception of geometry, and colors that shift with context, demonstrating the relativity of visual information. What we perceive isn't always a direct reflection of physical properties, it's an interpretation. These deceptions hint at something deeper, a hidden layer beneath the surface. What if our entire perception of reality is a grand, useful illusion constructed by our minds? A survival mechanism. Mathematics lets us explore realms beyond our senses, venturing into the unseen, uncovering patterns invisible to the naked eye, revealing the underlying structure of the universe. Take the square root of -1, a seemingly impossible concept once dismissed as imaginary, relegated to the realm of the unreal, now essential for understanding electricity, the very force that powers our modern world, and quantum physics, the bizarre and fascinating laws governing the smallest particles. Maths gives us a language for the hidden fabric of existence, allowing us to describe the indescribable, hinting at truths beyond our sensory grasp, pointing us towards a deeper understanding. This essay explores the provocative idea, a challenge to conventional wisdom, that reality as we perceive it is not the fundamental truth. It's just one layer. It may be a sophisticated interface, a user-friendly representation, shaped by evolution for survival, not for truth. Optimized for function, not accuracy. We'll see how mathematics, the language of the universe, including those once puzzling imaginary numbers, those abstract concepts, helps us probe this hidden side of nature, allows us to explore the unknown. What does this mean for our understanding of ourselves, our place in the cosmos, the universe, its vastness and complexity and consciousness, the very essence of our being? Prepare to question the world you thought you knew. Get ready to challenge your assumptions. The familiar may be just the surface, a thin veil over a deeper truth. Beneath it, a deeper reality awaits discovery, a world of hidden wonders. Our senses may be showing us only what we need to see, a filtered, selective view. Mathematics is our tool to look further, our lens to see beyond the surface. Let's begin the journey. Let's delve into the unseen. Imagine your computer's desktop, that digital space where you interact with files and applications, filled with colorful icons, each neatly arranged, promising access to a world of functionality, each representing complex processes you never see, a hidden universe of calculations and algorithms. The blue W icon isn't really a document, it's just a gateway. The folder isn't a physical object, it's an illusion of organization. They're simplified symbols hiding intricate code and hardware, a complex system distilled into manageable forms. If you had to interact directly with the transistors and software, with the raw data streams, you'd get nowhere. It would be an overwhelming, impossible task. The desktop interface hides complexity, presenting a simplified view, letting you work efficiently, focusing on your goals without being bogged down by technical details. My theory proposes our perception works the same way, acting as a kind of user interface for reality. What we see, hear, and touch are like desktop icons, simplified representations. Space, time, and objects are not the true objective world, but rather constructs of our perception. Instead, they're elements of a species-specific user interface, tailored to our needs and capabilities, shaped by natural selection, honed over millennia to promote survival and reproduction. The interface's purpose isn't to show us reality as it is, in its full complexity, but to guide adaptive behavior for survival, to help us navigate the world and avoid danger. There is something objectively real, a fundamental reality. Just as there's a real computer behind the icons, a physical machine processing information. But that reality is likely nothing like our perceptions, far beyond our current understanding. Our interface gives us fitness-enhancing symbols, simplified cues. A juicy apple prompts us to eat, providing nourishment and energy. A predator prompts us to flee, triggering our survival instincts. These icons are crucial for survival, guiding our actions in a complex world. Not for truth, not for a complete and accurate representation of reality. We don't see the world as it is. We see a filtered, processed version. We see what we need to see, what is relevant to our survival and well-being. Our senses are tuned for utility, for practical advantage, not accuracy, not for a perfect reflection of the underlying reality. The world behind the interface remains hidden, a realm of possibilities beyond our immediate grasp. Our perceptions are a practical fiction, a useful illusion that allows us to thrive. The interface theory challenges our deepest assumptions, forcing us to reconsider what we think we know. It suggests reality is stranger than we imagine, more complex and mysterious than our senses can reveal. We must look beyond the icons, beyond the surface of our perceptions, to understand the true nature of existence, to glimpse the reality that lies beneath the interface. The journey continues, the quest for understanding remains open. Mathematics ventures into realms that seem detached from reality, like the number I, the square root of -1. For centuries, I was dismissed as impossible, a mere curiosity. Yet imaginary numbers became essential in science and engineering, from electrical circuits to quantum mechanics. These numbers help us model aspects of reality beyond our senses, providing a language for the unseen and counterintuitive. Their utility shows that concepts once thought absurd can unlock the universe's secrets. Imaginary numbers are a metaphor. Our intuition about reality is limited. Just as I reveals deeper mathematical structures, perhaps we need new tools to grasp reality's hidden layers. The strange may be essential for understanding existence. Our models must evolve beyond intuition. Mathematics lets us probe what we cannot see or touch. The journey from impossibility to indispensability is a lesson in open-mindedness. Reality's code may be written in symbols we're only beginning to understand. Let's keep searching for the keys. Artificial intelligence learns from vast amounts of data, sifting through patterns and connections. It then begins building internal models, its own version of reality, a synthesized understanding of the world. An AI trained on images recognizes objects. It can identify cats, cars, and countless other things. And one trained on text generates sentences, crafting narratives and answering questions. It operates by constructing, not just reporting, it actively pieces together information. This construction is based on patterns it has learned, the statistical regularities it has identified. AI can hallucinate, creating plausible but fictional outputs, generating things that seem real but aren't. This can manifest as images of animals that don't exist, creatures born from the AI's imagination, or stories that blend genres, weaving together unexpected elements into something new. This mirrors human perception. Our brains construct reality from sensory input, piecing together sights, sounds, and smells. This input is filtered by experience and evolutionary bias, shaping how we see the world. What we perceive is not raw data, it's not a direct recording of reality. Instead, it's a carefully built model, a controlled hallucination. We experience a stable world because our brains make it so, actively maintaining a consistent picture. This is not because it's objectively true, but because it's useful for us. Understanding AI's hallucinations offers insight into our own minds, shedding light on how we construct our own realities. Our brains are prediction machines, constantly updating guesses about the world, refining our internal models based on new information. The reality we experience is the brain's best hypothesis, its most informed guess about what's happening around us. Vividness and solidity don't guarantee truth, only utility. Our perceptions are shaped for survival, not accuracy. The parallels between AI and human minds are striking. Both construct useful fictions to navigate the world. By studying AI, we learn about ourselves. The line between reality and illusion is thinner than we think. We experience space as 3 dimensions and time as a linear flow, foundations of our reality. Physics, from Newton to Einstein, is built on these concepts. But some scientists now question whether space-time is fundamental. Instead, it may be part of our species-specific interface, a data structure shaped by evolution. Mathematical explorations point to deeper structures beneath space-time, like networks of quantum information or geometric objects called amplituhedra. These frameworks don't fit our everyday notions of space and time. If space-time isn't fundamental, our deepest theories may need radical revision. The search for ultimate laws must look beyond our perceptual framework. Mathematics becomes our guide to realities we can't directly sense. The clock and ruler may not measure the true fabric of existence. Our interface is useful, but not the whole story. The real stage may be stranger than we imagine. Psychedelics like psilocybin, LSD, and DMT can radically alter consciousness and perception. Users report a dissolution of self and a breakdown of boundaries between self and world. The brain's normal interface is disrupted and familiar icons, objects, time, self, become fluid or vanish. New patterns, interconnectedness, and deeper layers of reality are sometimes perceived. These states don't reveal objective reality but show how constructed our everyday perception is. The brain still filters experience just in unusual ways. Studying psychedelics reveals the flexibility of our perceptual interface. They highlight the limits of our default perception. Altered states may offer clues to the hidden processes shaping our experience. Our senses don't passively record reality. They actively construct it. The brain uses complex mathematical operations to turn raw data into coherent experience. Bayesian inference is key. The brain combines new sensory input with prior beliefs to make its best guess about the world. What we perceive is the brain's most probable hypothesis, not necessarily what's out there. Our models are shaped by experience and evolution, optimized for survival, not truth. Evolutionary game theory shows that natural selection favors useful, not accurate perceptions. Seeing the full truth is costly. A simplified interface is more efficient. Our reality is a probabilistic best bet, a useful fiction. The mathematics of evolution points to perception as a tool for fitness, not veridicality. Our senses are tuned for action, not for seeing the world as it is. The interface is our evolutionary advantage. If perception is an interface, not a window onto reality, science faces profound questions. We may be studying the interface itself, not the world beyond. New mathematical tools are needed to model consciousness and the nature of objective reality. This challenges physicalism, the idea that everything is just matter and energy. If space-time and objects are constructs, the physical is part of the illusion. Consciousness may play a fundamental role in shaping experience. Understanding our interface is crucial for building intelligent AI. The quest to understand mind and machine is deeply connected. The world we perceive is a masterpiece of evolutionary engineering, a beautiful, useful story. But it's likely a carefully crafted fiction, an interface for survival, not truth. Mathematics offers glimpses beyond this perceptual veil. Concepts like imaginary numbers unlock deeper aspects of reality. Physics and consciousness theories push our intuition's boundaries. Openness to strange ideas is vital for progress and self-understanding. The mystery in the forest reminds us, what we see may not be the full picture. There's always more to discover. By embracing the interface theory and wielding mathematics, we probe reality's hidden code. The mysteries beneath the surface await our investigation. Let's keep searching for what lies beyond the interface.